Hello.
Hi,
Hey, how's it going?
good. How are you?
Pretty good.
Can you give me a little background about yourself?
Sure. So I guess I'm I'm getting a bit of feedback from the mic. I can hear myself speaking.
Oh,
I don't know if that's yeah, okay, that seems to be fixed.
is it
Right.
better now?
Yeah, I don't think I can hear myself. So I guess just some only a little bit. I guess the background is I'm a student studying computer science at the University of Toronto. I
Oh,
did a couple of other internships previously.
hmm.
And right now I'm just looking at new grad roles.
Okay. All right. You've used this platform before?
Yeah, I've done a couple of interviews on here.
Okay, awesome. What's your preference for language?
I'll go with Python for interviews. I'll just switch that over right now.
Great. I'll just paste the question here, and we can start.
Sure.
So we need to find the longest substring which does not have any repeating characters.
Right. Okay. So I guess going straight into that, can I assume that these are all say ASCII characters?
Yes.
Okay. For the actual solution, I don't think I'm gonna work with that constraint. What I'm thinking is I can let's say use these two separate pointers in order to determine what some window of candidates might be.
Okay.
So let's say I have a set, which is going to be filled with the items that are inside of my window. So I'll have a
Uh-huh.
window that's initially set so that both the start and end pointer are going to be at the 0th index, and I'll have a
Okay.
set initialized to the empty set. I want to keep iterating and moving forward my end pointer until I find a new character that is already within my set. And this is with the portion that every single time that I am adding items or I am moving my end pointer forward, I'm gonna add items into the set.
Okay.
Um, so my substring or my length of my substring is dependent on the distance between my the distance between my end and start pointer.
Mm-hmm.
And once I've lost this sort of like invariant that I want to keep, that the set or that start and end only has unique characters, I keep on moving up the backward pointer until it's
Okay.
met again, right? That my set has all unique characters,
Okay.
or the window has all unique characters, because the set, of course, has all unique characters. The
And
complexity for this. Oh, sorry, we're going to say something.
what if you find a character that's already in your set?
Sorry.
What if you find what if your end pointer encounters a character that's already in your set? What
Right.
happens then?
So yeah. So I was saying there in that case, I move up the backward pointer, right? So that I keep on advancing forward, and I remove items from the set until I find that that this character, the one that the end pointer is no longer in the set.
Okay. Okay. Go ahead with the
Yeah.
complexity.
Sure. So the complexity for this ends up being big O of n. It's linear time where n is the length of the input array.
Hmm.
And that's pretty clear because we're just, iterating through the array once, right?
Yes.
And the space complexity is constant, just because we're using these two pointers and nothing else.
Yes.
I want to say that this
Hmm?
should be pretty optimal. Is it okay if I go ahead and code this out?
Yes. Yes.
Cool. Okay. Def longest substring. And we said our start and end are going to both equal 0, 0.
Okay.
So, we also have longest set to 0. Right, so let's think about what the outer loop would actually end up being. Would we want to have it continuing until end
Yeah.
hits the length of s? I don't think so. I think you'd want to have it while start is less than length of s. Um, just because you may have the condition that the longest is actually let's say we have like A, and then AB. I don't know if that's the correct case, but the end will end up hitting the actual end of the array before start will. So our longest substring is going to be that final AB, right? So we want to make sure that start goes far enough.
Yeah.
Right. So I'll keep this as one of S, and I'll see if I need to do -1 afterwards. Right. So let's translate what I said I would do earlier. The first part is I want to check the current element and see if it's in the set, or whatever's at end is if it's in the set. If it isn't, then I add it and move forward. So say if s then in found, not in found, we're gonna found.add and end. Let's just assign these as variables. Val equals end. Start val equals start. If end val not in found, then we add it, and then we move up by 1. Otherwise, we want to keep on, moving up the forward character, right? Until you don't have that the end val is in found. So there's also supposed to be a check for longest is equal to max of longest minus n minus start. And otherwise, we do found remove start val. Start plus equals 1. So I think that covers most of it. I think it'll probably be helpful to run through a test case to see, because I'm pretty sure there's one more branch in here. So it'll probably be useful to go through an example to figure out what that is, or just maybe reason through it. So let's say I have the input you gave ABC. So I'll start off with both of the values start and end being 0. I'm going to yeah, okay. So this should definitely have an out of bounds is one thing. So right off the bat, I would want to check what's called if my end val is actually less than, or my end is less than len of s. Yeah, it doesn't work out because I set my end val earlier to being s of end. So I actually have to use s of end anyways. End less than len s, and whoops, I just butchered this. Just to summarize what I did, I can't actually assign the value because I said earlier that I may keep on advancing the backward pointer but not the forward pointer, right? Because the forward pointer may already be past the end of the array. So this was just an out of bounds error fix. But continuing. What I have is, right, I'd start off, I'd see that A is not in the set, so I'll add A, and then I'll move end by 1, and now my longest is 1. Next time through, I will see that B is not in, and so not in found, so I'll add B and then move up by 1. Now my longest is 2. Next time through, I see C is not in, so I'll add it, move up by 1. Cool, now I encounter A as my end val, and end val is less than S, but S is in found, so I'll hit the end case. So what I end up saying is that I'm going to remove the A, and I'm going to move my start up by 1. So okay, now my start is at index 1, and my end is at index 2, or my end is at index 3. Next time through, my end val is still the same, but now I see that I can add the A, so now my longest is BCA. So for the general case, I think these cases work out. The thing I want to check though is the situation in which I actually go all the way to the end of the array. So my end is already out of bounds, but my start isn't. Let's think of a test case that actually has that. What is a good way to make sure that my end is already done? Because let's think about this. Is it ever the case that my actual longest substring is going to be something at the very end?
Yes.
If I have right, but I'm not sure what the value of start would be in this. So okay, let's go with what I said, the bunch of A's and then a B. I can just make this shorter to go through it quicker. So first time through, my found is added, or A is added to found. I move up. Now I see that it's the same value. So my start and end are both at index 1. Next time through, I'll get at the position again where my start and end are at index 2. And so here my start is already at the position that I want. It's at index 2. My end is going to move forward once, and it's going to say, I'm going to add B to the set, and then next time through, okay, I see, there was an error with this. What I ended up saying here was that my longest is going to be length 1, but that's not true. My longest is length 2, and the reason it doesn't work out is because I don't actually have a branch to handle when end goes outside of the length.
Yeah, in your while loop, you can actually test for your end instead of the start.
Yeah, I think that makes a lot more sense. Just because the only time that the else will run is when I don't have a valid substring, right, without repeats, and it is impossible for my value for start to get larger than my value for end. So I think this fixes that. But I still have an off by 1 in the sense that when I get to the end, yeah, I can remove this. But when I get to the end, I'm not actually, checking the final set, right? So let's say I have a longest substring that is this. It's just a bunch of A's. Will I get the correct answer? Yes, in this version, it's okay. So the last case is still the one that I want to check. I'm thinking it might be fair to say that I can just do longest equals max of longest comma and minus start, but I don't think that's necessarily true.
I don't think you're this one.
Sorry.
I don't think you require to check the longest again. Whatever you have before, it checks even if your longest string is towards the end of your array.
You're right. Okay. I made a typo in my head when I was doing this. In the example of AB, my end is incremented first and then I do the check. So you're right. The example of AAAB will return 2 correctly. I thought I did that the other way around for a second, but yeah.
Because initially you had your while loop starting, with the start less than length of it. So it might be a little confusing, but this is perfect.
Yeah, so I think this ends up being my final solution. The only things you'd need to check for are edge cases, such as the empty array. And if that's the case, I just don't, I don't go through the loop at all, right? And I just return 0. The only other case, if I actually get invalid input of none. Cool. So yeah, should I run this with?
Just a question. I'm not familiar with writing in Python, but if S is none, does it handle both empty and null case?
If S is none, that only handles the null case. the while end is less than len of s, that'll cover the empty case. So if s is equal to this, that'll work out. Yeah. Is it okay if I run this?
Yes, please.
Cool. I actually forgot if I'm not sure if I can actually, I just forget if you can actually operate with strings in Python. Let's see. There. Cool. So I gave 3, which is correct. The more important cases I want to cover are empty string and the AA. Cool. So those both worked out, and I think that should be most of the cases. The other one I can think of is just all A's. But reasoning through the code, I think this should work out.
Yeah.
Cool.
That's good. Cool. Okay, this one went really well. Shall we go with the next question?
Sure. Let me just move this down.
Okay, let me add the next question.
Okay.
So let's say you know how the IP addresses are. So for example,
You have the 4 octets.
yes. So here, it has 4 octets, like you said, and everything has digits between only maximum 3 digits, only values between 0 and 255.
Okay.
Only then it is considered a valid IP address. So 255.255.255.255 is still valid. But let's say it is 300, then it is not valid. Say something like 300.8.9.9. This is invalid because any slot cannot have a value which is greater than 255.
Right. Sorry, just repeating again. You're saying the range is just 1 to 255?
0 to 255.
0 to 255. Right. Okay, that makes sense because that's exactly where IP ranges go.
Yeah.
Cool. Okay, so from my understanding of this question, what I'm basically doing, or what I'm getting is I have an input string that could be of any length. And sorry?
Yeah, it could be of any length.
Okay, and basically what I want to do is parse through and determine in which locations I can actually place the dots in order to separate it. So in this example, I got 255, 255, 11, and then 135. And the alternative option is to do 111 and 35. Okay. Just thinking through ideas, I figure that using recursion in this is probably going to be relevant. Is it always the case that I want to break it into 1 space, 2 space, and 3 space segments? I think so. So as a naive option, what I think I can try and do is, let's say I have my input string, and what I would do is I'm going to say, I'm going to pick putting a dot after 1 character, after 2 characters, or after 3 characters, and then that's my first segment, and then I recurse on this 4 times. And at each of the steps, each of the recursive calls, I would just want to check, oh, is this a valid, is this a valid IP? Or not IP, is this a valid range? If yes, continue in the recursive calls. If it isn't, then just backtrack. This definitely works as a solution. It's going to end up having a pretty insane complexity of, say, like it's exponential. I want to say it's 3 to the n, but is that actually true? If I define n as the length of the input.
Like if
Sorry?
at all you had, let's think it this way. Let's say you have to sit down and write down all the IP addresses ever possible. How many IP addresses would there be possible? Is that a finite number or is it an infinite number?
Yeah, that's a pretty finite number. So that's why that 3 to the n doesn't sound entirely correct. Just because, like, if I think of it in terms of the branches in the recursive call tree, then it is, but there's a limit to how far that can go, right? And I'm only going down 4 stacks max. So really, I guess it is, no matter what, kind of like constant time. Yeah. Just the representation of the code makes it look, exponential.
Correct.
It's cool. I think that does end up being okay as a solution. There's some optimization I could make in the sense that I know that there's absolutely no way I can pick one item if it turns out I have, 3, 12, 14 digits left. Like, there's no way, right? It has to be 3 digits that I pick there. But that sounds, as the naive approach, I don't think I should really have to do that. Is it okay if I go ahead with the recursive approach that I talked about?
Yeah, go ahead.
Sure. Okay. Def valid IPs on S. Right, just because I can't actually work with strings themselves, I'm just going to convert it into a list to start off. And then I can have a result array, and I should be able to make a partial, which is going to include all of the numbers in the current set of calls. So let's use an inner function. So I'm just using nested functions just so that I can, instead of passing the values, I can refer to the result and partial array in the larger scope. So all I'm going to be doing is saying that I have some directed valid IPs, which keeps track of which index I'm currently picking at in the string, as well as how many picks I've made so far. So right off the bat, I'm at the 0th index, and I've made 0 picks. So what I'll want to say before I make the base case is that I either append to the partial, like my partial solution, 1 character, 2 characters, or 3 characters. So I append s from ind to ind plus 1. And then this is one recursive call. Otherwise, I pick 2 characters, or otherwise I pick 3 characters. So I can just kind of copy and paste this and make more recursive calls. One option is to actually just pop off the values every time, but because I know that it's the same values, I can just add along. Wait, is this true? Yeah, I should just be able to add along, and I think it's only in the final section that I'll have to pop 3 times. So I'll have to do partial.pop, say, 3 times in here. Plus 2, plus 3. Right, so just again summarizing what I did, I decided to add the first character and see what happens if that's my pick. Otherwise, I add 2 characters and I see what happens if that's my pick. Otherwise, I pick 3 characters and see what happens if that's my pick. In the base case, I end up having that my pick is just equal to 4, which means that I've added 4 items. So if pick is equal to 4, and I find that my ind has picked all of the elements possible, then what I would have is I found a solution. wait, oh, it's supposed to be len. Result.append my partial, and then I return. If I found that my end, sorry?
Sorry. Is Python pass by reference or pass by value for method?
It's the same as Java, where it's a pass by assignment. So
Your pick is a variable, like an integer variable. Do you think it will carry the same number that you're sending from the previous stack?
oh, so when I'm using the numbers, those are just going to be, the numbers I pass down, right? So pick is directly from the directed value IP's function argument.
Oh, so it does carry the, let's say, does it remember that I'm sending? Okay, go ahead.
Yeah, the only confusing part would be the partial thing. Because I have these nested functions, it's just following like a normal lexical scope, and it's going to the previous block. So this partial on line 18 ends up referring to the same partial as line 12. Cool. So, right, that is my base case. There's also the cases of actually handling whether I have a valid IP. So the easiest way I can think of to do that is to just check whether the number that I have is within the range of 0 to 255. But there is a problem with that in the sense that if I have 0 and I have 22, that obviously doesn't make any sense at all. And that could end up happening if I just if I add the next 3 elements, and I make a recursive call and just check if my integer is, within 0 to 255. I want to say that this is a edge case that I should be able to handle by just checking first that the 0th index isn't 0, and then doing the second check of 0 to 255. Because any other place that 0 is in, it's fine. Like I can do 202 or 200. Those are still valid. Let's say if len of partial not equal to 0, what we want to do is just translate that idea. If partial of what did I say would be? -1 of 0 is equal to 0. Int of 0. Is it easier if I store everything as strings or integers? I'm going to say it's probably easier if I just keep everything as strings. Yeah. 0, then we return. Otherwise, the other case is that if int of partial -1 is equal to let me just assign this to make this easier. Current range equals that. Right, so one case was us saying the current range, the 0th index, if it's equal to 0, then return. Otherwise, it's that I have int of current range is greater than or equal to 0, int of current range. I want the opposite of this. Sorry, mixing this up. It should be that if it's I mean, I can't ever have less than 0, right? So I guess the only case that I have to check is that it's the value is greater than 255. So that should be the real invalid case. Yeah, because it's impossible for me to get negative values here, right? Oh, this is a typo. Cool. I want to say that this should end up being pretty much the translation of the idea. into the correct recursive calls, but it's probably helpful to go through an example here. Or even before that, just reason through it. So, right, so I have my list of S. There is an error. Sorry?
Yeah, so I was just saying, what if your range is like 1004? Do you think it will cover the case? What if the length is greater than 0, like 1004? Then the integer value of that will be greater than 255 and you return. Okay. Okay.
What do you mean 1004?
Just in case you have the more than 3 in your partial, in your current range, if the number of digits are more than 3.
Right. Okay. So there definitely was a place that I messed up on this. And this is the part where I was appending to the partials. So I said earlier that I could just append to the partials the individual items, but that is not true. Because initially I was supposed to have, say, values like 255, 255 inside the partial. And internally I would build up the 2, 5, and then 5. But instead what I'm doing is 2, 5, and then 5, which is an error. So yeah, that's one of the bugs. There's another bug as well on line 18. I'm actually not appending the correct thing to the result, but we can fix the partial append portion first. So just the easiest way would be to just pop one element, then pop 2 elements, then pop 3 elements. The alternative is if I were to do kind of like a -1, right? Because this is saying that I'm going to append one string, but I can't do that because this is I keep forgetting, immutable strings in Python. If I use the -1, it would say that I'm adding just one character to the end of the last string. I want to try it this way first and see if I can actually do that. It's like plus equals. Yeah, I want to say that this kind of works out as code, but it just looks really messy if I do it like that.
Sorry, I can't help you with the syntax here because I usually write in Java. But I can help you with the last.
Maybe one way I can make this at least a little bit cleaner is if I do that, so that at least it's the same everywhere. Okay, like for a string, if I have like x equals a, then I can do something like this. Now it's x is ab and it's being mutated, but I can't actually append. If I do that, yeah, that's not a valid operation. Then I only need to parse.pop once.
You have something like that?
I'm sorry?
So in Java, there's something called string builder where you can append strings to it. But I don't know if such a similar thing exists in Python. Do you want me to check?
Yeah. Well, I can explain what ends up happening here between line 28 and line 38. So basically all I'm saying is that my current octet is going to be inside of this list. Is that really required? Yeah, I guess that's an easy way to separate the values, right? And then what I'm saying is in the last value inside of my partial, I'm going to first append one character, then 2 characters, then 3 characters, and then I'm just going to remove that entire octet when I backtrack. It does work out. It's just kind of messy in that the final value type that I'll get, it's going to be a list. Partial is going to be something like this. Well, these are all going to be strings. And then it's going to be, let's say, 101, and onward, right? Instead of just having the strings directly.
Yeah, it's because you converted the string into the list in the first place.
Yeah, that's not what ends up making the difference. It's more because I do this partial dot append, and then when I do the plus equals on specific characters, I just add to that existing inner array. I'm struggling to think of how I can actually do this without using the inner array, because I can't just use plus equals every time. Yeah, I'd need some separate way to, well, I don't need to use the list. The other option I have is to just, put in the dot over here. Like if I were to do partial dot append, and then I put in the entire substring and then add a dot, that should still work out. It's roughly the same-ish, I want to say, in terms of logic, at least. But it changes how I end up actually combining my final result to add to the result, or my final partial. So right, I have some string here, or some list that's of the form, say it's strings of 255, 255. So I'm going to say that the solution should end up equaling to dot join on the item of 0 for item in partial. Yeah. Right, so that should fix up part where I actually wasn't appending the correct result. Right, so back to going through an actual test case of this. Now that we've reasoned through some of the larger bugs. Sorry, I don't know why this result is highlighted. Did I forget a parenthesis somewhere? Yeah, I'm not sure why result on line 19 is being highlighted as a syntax error. The brace is closed correctly. Wait, what? Oh, I'm still running the stuff at the bottom. Yeah, I guess we'll figure it out when we run it, but going through the actual test case, I had this 255, 255, 111, and then 35. Right off the bat, I'm going to say that I have nothing as the solution. My partial is empty. I have my 0 picks, and I'm at the 0th index. So cool. My pick isn't equal to 0, and my length of partial is still equal to 0, so I skip this check. And what I say is I'm going to append a list, and onto the final element there, I'm going to add the item at the 0th index, and now I'm going to recurse. So cool, one of my items now is 2, and now I've recursed on the rest of the string. So going through again, my length of partial this time is non-zero. So my current range is the last item. I see, I check if the value at the 0th index of the current range is equal to 0. It isn't, and my current range isn't greater than 255, so cool. Again, I'll end up backtracking, and I'll pick the next character, which is now a 5. And this should end up repeating over and over again, except it'll end at 4 when my pick is 4. And so now my octets are 2, 5, 5, and 2. I check my int is not equal to the length of s. That means that I don't have a solution. I return. This backtracking should work out for all steps. Yeah, I definitely couldn't go through all of them because it's pretty extensive. So let's say that, yeah, I picked the second item and I picked the third item like I said I would, and then when I have an octet value of say 255, this one pop operation should get rid of it. So cool. Let's pretend that I have a valid solution. Because I kind of reasoned about the partial not equal to 0 portion earlier. What will I get here? 5, 255, 255, 5. All I'm doing is saying that the item of 0 for each of the items in partial is what I'm going to add and put a dot in between them. So that should give me exactly what I want. Yeah, and so this looks pretty okay to me. If I run this with the actual test case, I'm sorry, that just cut out. Hello?
Yeah, go ahead. Yeah, go ahead and run with
cool,
that.
Cool. Print valid IPs on 255, 111, 35. And there seems to be a syntax error here. I don't know what that is, but I guess I'll find out.
Yeah, sure.
Int argument must be a string. Says this on line 26. Oh, right. I forgot. I converted this into a list. So it should be the last item and at the 0th index. Huh. Okay, there's definitely strange. Pick 2551. Huh. Let me just print off what I'm actually getting as a partial value here. 25525. I think my actual check between line 23 and line 89 may be incorrect, but I actually didn't find any valid solutions at all from this.
Yeah.
So it can't be just this one section.
Just the way you're calling the recursion again, can we check to see if that's correct? The
Sure.
way you're recursing directed valid IPs.
Yeah. So what I'm saying, or what actually might be more helpful is printing off some of the stuff here. What I'm saying for the recursive calls is I've either picked one item from the set from one index moving forward, or I've picked two items, or I've picked three items. But the actual thing that I'm adding in, that may be wrong. So if I were to print off partial at this point, and then print partial right after, I think that may be a good clue. Yeah, so it definitely seems like, oh no, this is actually okay. So I've added, oh, it's because the plus equal is actually, right, so it didn't actually add in a string like the way that I expected. For example, the 255 that I have here, if you check the output, it isn't actually one string together, but it's multiple items inside of a list.
Yeah.
Yeah, which is definitely way off. That means instead, I guess one option is to just have multiple joins, right? This seems kind of strange to do, but I guess it's a consequence of my earlier decision to put everything inside of a list. So if I had, instead of item 0, I had dot join on item, I think this actually merges together that 255, 255, 111, and 3. Yeah, so that's part of the problem fixed. And that now my final solution is an actual, octet, right? So the only thing left to fix at this point is the lines between 21 and 27. Because over here I can see that there's definitely some things that are invalid. I have a 511 and a 512 and a second 511. The two final solutions are correct. So what I have here for current range is the error. Yeah, so when it's looking at current range, it's only looking at the 0th index item. So again, pretty much end up having to do this to convert it into one string. And now I have the correct solution for the case that you gave. Cool. I want to say that this is probably okay with all inputs, because even if I have something ridiculous, like let's say I have this just repeating a bunch of times, it should definitely not give a solution, because I should never end up hitting the case where my ind is equal to len. And that's correct. I got nothing back as the solution, just because I exit as soon as my pick is equal to 4. So cool. That will be my final solution.
That's great. That's awesome. So the time complexity is still constant because we know there are 2 to the power 32 valid IP addresses that could be generated.
Yeah, and it's not only that, it's also that I only make 4 selections, right? After I have my 4 octets, like it's done. There's no more recursive calls.
Yeah. All right, cool. That went great. How were the questions? Did you find them easy? Did you practice them before, or how were the questions?
Yeah, the first one I'd say I got pretty quickly. There's just like a small bug you could get. The IP one I have not, or even if I did, it would have had to have been years ago. This was pretty good. Yeah, I definitely enjoyed the IP question.
That's good. Okay, I really like your performance. Like